Florida senators have a new way to fight invasive Burmese pythons in the Everglades.
Yep, we need to share this with you and how drones could be used for the future of python hunting.
A drone camera sweeps over Florida's Everglades. Shallow water, sawgrass. Everything looks normal until something beneath the surface starts to move. Not an alligator, not a snake, something bigger. A dark shape sliding through the marsh, pushing the ground upward as it goes. 60 feet of vegetation rippling in a line. Then, a second shape appears, moving parallel to the first. And then the earth between them begins to shift. The operator had filmed the Everglades for years. He thought he knew what lived down there. He was wrong. When scientists analyzed this footage, they didn't ask what it was. They already knew. And their reaction wasn't curiosity. It was alarm. Because what's moving beneath Florida's Everglades is something nobody talks about. Something that threatens the drinking water of 7 million people. And it's happening right now. Here's what they discovered. Not a swamp, a river. Before we can understand what's happening below, we need to shatter one of the biggest misconceptions about the Everglades. Most people think it's a swamp, stagnant water, thick mud, mosquito clouds, the kind of place you'd want to avoid at all costs. That's completely wrong.
These Everglades, a profusion of 10,000 different islands, many untouched.
The Florida Everglades isn't a swamp at all. It's a river. A massive, slow-moving river like nothing else on the planet. The Seminole people who lived here for centuries called it Oki, grassy waters. They understood what took European settlers centuries to figure out. Marjorie Stoneman Douglas, the conservationist who fought to protect this place, called it the River of Grass in her famous 1947 book. And that name isn't poetic exaggeration. It's technically accurate. Here's the deal. The Everglades flows southward from Lake Okeechobee to Florida Bay. According to the National Park Service, this river of grass can stretch up to 60 miles wide during wet season, but it moves at an almost imperceptible pace. During summer, the river flows at roughly 1 mile per day. In winter, just 100 feet per day, barely moving, but always flowing. And get this, the elevation drop across this entire system is only about 2 to 3 inches per mile. Water leaving Lake Okeechobee might take months, sometimes years, to reach Florida Bay. But here's what most people don't realize. Beneath this slow-moving sheet of water, beneath the sawgrass and the shallow marshland, there's something else entirely. A thick layer of ancient organic material that scientists call peat. And that layer, it's not as stable as anyone thought. Not even close. The foundation that's falling apart. Dr. Xavier Comas has spent over 15 years studying peat soils. As a geosciences professor at Florida Atlantic University, he's mapped these organic deposits across the Everglades, getting his boots muddy in places most researchers never see. When he describes what lies beneath the marsh, his voice takes on a quality somewhere between wonder and warning. Peat soil in the Everglades isn't just dirt. It's not mud. It's not sediment in any conventional sense. It's thousands of years of accumulated plant matter, sawgrass, water lilies, and other vegetation that decomposed in the oxygen-deprived environment beneath the water. This process has been ongoing for roughly 5,000 years, layer after layer, generation after generation. While the rest of the world was building pyramids and empires, the Everglades was building something else entirely, a foundation that can range from a few feet to over 10 feet deep. And here's what makes this material truly remarkable. Peat can have a porosity of up to 96%. Think about that, 96% water and air, only 4% solid material. Dr. Comas describes it as so soft and spongy you can cut it like cake, or dig through it like making sandcastles at the beach. It almost defies logic that material this porous can still support your weight when you step on it. And sometimes it can't, because peat behaves in ways that solid ground doesn't. When it's saturated with water, it acts like a semi-fluid mass. When water drains away during dry seasons, the peat shrinks, it cracks, it shifts laterally. When water returns, that's when things get strange.
Within this expanse of sawgrass and these stands of mangrove and cypress,
Peat can float, it can slump, it can slide. And from above, this creates the visual illusion that the ground itself is moving. Because technically it is, but the scale of what's happening now, that's the part nobody expected. And that's putting it lightly. the numbers that made scientists go pale. Researchers with the U.S. Geological Survey have been tracking peat destabilization in the Everglades for decades. Dr. Comas and his colleagues have used geographic information systems to compare historical and current elevation data across the entire ecosystem. When they finally compiled the numbers, they had to run them 3 times before they believed what they were seeing. Parts of the Everglades have lost more than half their original peat depth since the mid-1900s. Half. Gone. In less than a century. In the Everglades agricultural area south of Lake Okeechobee, the losses are even more severe. A study published in Agriculture, Ecosystems, and Environment calculated that roughly 4.5 billion cubic meters of peat soil have been lost over the past century of drainage. That's equivalent to approximately 250 million metric tons of peat mass. The carbon dioxide released from this decomposition alone totals nearly 500 million metric tons, a staggering amount that nobody anticipated. And here's what makes this terrifying. Once peat collapses, it doesn't come back. Not on any timescale meaningful to humans. Not in our lifetimes. Not in our children's lifetimes. Remember, this material took 5,000 years to accumulate. 5,000 years of slow, patient building. Its destruction is measured in decades. The USGS has documented extensive land subsidence. That's the scientific term for the ground literally sinking, caused by drainage and oxidation of these organic soils. Their reports explicitly state that this subsidence will greatly complicate ecosystem restoration and also threatens the future of agriculture in the Everglades. When researchers capture footage of the ground moving beneath the marsh, they're not witnessing something new. They're witnessing an ancient system in the process of collapse. The movement is becoming more frequent, more visible, more concerning. But the peat was only half the nightmare, because what researchers found moving through those underwater passages, it made the ground movement look like a minor inconvenience. The invasion nobody saw coming. In the shallow waters of the Everglades, something else is creating those long, sinuous disturbances that thermal cameras keep picking up. Something that doesn't belong here. Something that was never supposed to exist in this ecosystem. Burmese pythons. These massive constrictors are native to Southeast Asia, Myanmar, Thailand, Vietnam. They have absolutely no business being in Florida, but they're here. And they're thriving in numbers that have transformed this ecosystem into something unrecognizable.
A place to release them, and that ecosystem in the Everglades is uniquely similar to their native habitat in the Southeast Asian range.
The invasion likely began in the 1980s when pet pythons were released or escaped into the wild. At first, nobody thought they could survive. Florida winters would kill them, experts said. The environment was too different from their native jungle habitat. They were wrong. Catastrophically wrong. The Burmese python found the Everglades to be nearly perfect habitat. Warm temperatures year-round, abundant prey with no experience avoiding this type of predator, and critically, no natural predators large enough to threaten an adult python. So here's the deal, these snakes now number in the tens of thousands. Some estimates suggest over 100,000 pythons infest the Everglades ecosystem. That's not a typo. 100,000 apex predators that shouldn't exist here, and they're not small. According to the Florida Fish and Wildlife Conservation Commission, the heaviest Burmese python ever removed from Florida weighed 215 pounds and stretched over 17 feet. That snake was captured by Ian Bartosik with the Conservancy of Southwest Florida in December 2021. But here's what happened just days ago. In January 2026, FWC contractor Carl Jackson and 3 family members captured the second heaviest python on record, a massive female measuring nearly 17 feet and weighing over 200 pounds. When they examined her, they found something chilling, approximately 200 eggs developing inside her body, 200 potential new pythons. That will never hatch. The longest python ever captured in Florida? 19 feet, longer than most cars. It's not that simple though. What makes these snakes particularly eerie on drone footage is their behavior. Burmese pythons are semi-aquatic. They swim fully submerged. They travel through underwater tunnels in the peat layer. They move beneath vegetation mats without ever breaking the surface. From above, all you see is vegetation rippling, water bulging, a dark shadow sliding through the marsh, and then nothing. If you want to stay ahead of discoveries like this, hit subscribe, because what we're about to reveal next is the part that changes everything about how we understand the Everglades. The ancient engineers. The American alligator has lived in the Everglades for millions of years, long before humans set foot on this continent, long before the pyramids, long before almost everything we consider ancient. And unlike the invasive pythons destroying this ecosystem, alligators don't just inhabit the Everglades, they literally build it. Dr. Frank Mazzotti at the University of Florida has studied alligator ecology in the Everglades for decades. His research team has documented something remarkable. Alligators are what scientists call ecosystem engineers. This isn't poetic language, it's a scientific classification for species that fundamentally reshape their environment in ways that benefit countless other organisms. Beavers build dams, coral creates reefs, and alligators, they dig. Using their snouts, claws, and powerful tails, alligators excavate depressions in the peat and limestone. These fill with water and remain wet even during severe droughts. Scientists call them gator holes. Dr. Bradley Strickland, who led groundbreaking research at Florida International University on alligator ecosystem engineering, made a discovery that surprised even veteran researchers. His team found that alligators actively move sediment and nutrients around their holes, enriching the soil and fundamentally altering the biogeochemistry of the entire marsh system. They're not just living in the ecosystem, they're constantly reshaping it. And they've been doing it for millions of years. But here's what creates those shocking visual disturbances on camera: large alligators. And we're talking animals that can exceed 14 feet and weigh over 800 pounds, regularly move between gator holes through underground tunnels and passages they've excavated in the peat layer. When a massive alligator pushes through one of these subterranean channels, it can displace entire mats of peat and vegetation above it. From a drone hovering above, this looks like the ground itself is rippling. Water bulges upward against the current. Sawgrass bends in waves that have nothing to do with the wind. And here's the connection that has researchers deeply concerned. Alligator holes depend on healthy peat layers. When peat destabilizes and subsides, these critical refugia change or disappear entirely. The ecosystem engineers are losing the raw material they need to do their work. The feedback loop from hell. So, we have three phenomena creating movement beneath the Everglades: peat destabilization, massive invasive pythons, and alligators reshaping their environment through underground passages. None of these are mysterious. All of them are scientifically documented and well understood. But here's why scientists are alarmed. The scale and frequency of visible ground movement is increasing, faster than any model predicted. And that matters because destabilized peat doesn't just change the landscape, it releases what was trapped inside for thousands of years. Dr. Tiffany Troxler directs FIU's Sea Level Solutions Center. Her team has been tracking what happens when peat collapses, and the results made headlines for all the wrong reasons. When peat dries out and oxidizes, or when it collapses entirely, it releases massive amounts of carbon dioxide and methane, two of the most potent greenhouse gases affecting global climate. The Everglades, which spent 5 millennia acting as a carbon sink, is now becoming a carbon source. Ben Wilson, who conducted his PhD research on this phenomenon at FIU, found something that made his team run the calculations. Multiple times, some parts of the Everglades can release up to 3 times the normal amount of carbon dioxide when salinity levels increase and water levels drop. 3 times. Not a small uptick, a dramatic spike. Wilson calculated that carbon potentially lost from the Everglades during these destabilization events is comparable to the carbon dioxide emissions of 35,000 cars annually. And that's from relatively modest salinity intrusion events, not worst-case scenarios. And it gets worse, much worse. Peatlands worldwide store approximately 1/3 of all terrestrially accumulated carbon, 1/3 of all the carbon stored in land-based ecosystems on the entire planet. The Everglades contains one of the largest contiguous deposits of organic peat soils in the continental United States, originally covering more than 8,900 square kilometers. When this carbon storehouse collapses, it doesn't just release emissions. It creates a feedback loop that accelerates its own destruction. The released carbon contributes to warming. Warming accelerates sea level rise. Rising seas push salt water further inland into the Everglades, and salt water kills the freshwater vegetation that creates new peat. Wilson's research documented that 65% of plant roots in freshwater marshes and 72% of roots in brackish water marshes died due to increased salinity from sea level rise. No roots means no new vegetation. No new vegetation means no new peat formation. Less peat means less water retention. Less water retention means more saltwater intrusion. And the cycle accelerates, each year faster than the last, each season worse than before. 7 million people. The Everglades isn't just an ecosystem. It's not just a national park. It's the primary source of drinking water for over 7 million Florida residents. The same system we've been discussing, the same peat layers that are destabilizing, the same water that massive pythons swim through, provides the water that comes out of taps in Miami, Fort Lauderdale, West Palm Beach, and dozens of surrounding communities. The porous limestone bedrock beneath the peat is the Biscayne Aquifer, one of the most productive aquifers in the world, the sole source of drinking water for Miami-Dade, Broward, and Palm Beach counties. There is no backup. There is no alternative. When peat collapses, water quality degrades, nutrients locked away for centuries, including phosphorus from decomposing peat, release into the water supply. USGS researchers have documented phosphorus accumulating in surface peats near canal discharge areas at rates 100 to 1,000 times greater than in remote areas. 100 to 1,000 times greater. That's not a slight increase, that's a transformation. This nutrient loading has already caused dramatic shifts in vegetation. Native sawgrass, adapted to low phosphorus conditions for millennia, is being replaced by invasive cattails. The character of the Everglades is changing before our eyes, acre by acre, year by year. The question they won't answer on record. Here's what scientists know for certain. They know what's moving beneath the Everglades. Peat soil shifting as it loses stability, massive pythons navigating underwater passages, alligators reshaping the landscape through gator holes and underground tunnels. None of this is mysterious. All of it is documented. But scientists didn't expect to see this much movement, this often, this visibly. Development and water management have reduced the original Everglades wetlands by half of an ecosystem that existed for thousands of years, gone in less than a century. Wading bird populations have crashed by 80% since the 1930s. The Florida panther survives in numbers of only 100 to 180 adults, occupying just 5% of their historical range. The peat foundation keeps subsiding, inch by inch, year by year. But here's what has some researchers quietly asking questions they won't put in official reports. If peat destabilization is accelerating this fast, and the python population has exploded beyond any model's predictions, what happens when these two phenomena collide in ways we haven't seen yet? What happens when underground python tunnels intersect with destabilizing peat? When massive constrictors move through already weakened soil structures? These aren't hypothetical questions anymore. They're happening, right now, in real time, and the footage is capturing every moment of it. What we're really watching. So, what did that footage actually capture? Something real, something moving below the surface, something with consequences for millions of people. Not a monster, not a secret experiment, not an undiscovered species lurking in the depths. It captured the Everglades, showing us exactly what it's become, an ecosystem in collapse, an ancient foundation dissolving beneath South Florida while most people have no idea it's happening. Ancient peat layers that took 5,000 years to form are destabilizing beneath our feet. Massive invasive predators have decimated native wildlife. Populations that took millions of years to evolve, wiped out in decades. And the alligators that have shaped this landscape since before recorded history are fighting for survival alongside everything else that calls this place home. The footage is alarming precisely because it's not mysterious. Scientists know exactly what's causing the movement. They've studied it carefully for decades, published hundreds of papers, presented at countless conferences. They just didn't expect it to become this visible, this frequent, this completely impossible to ignore. The ground isn't supposed to move this much. The disturbances aren't supposed to be this common. The system isn't supposed to be failing this fast. If the peat continues destabilizing at current rates, we're not just losing a national park. We're losing the water supply for 7 million people. We're releasing centuries of stored carbon into an already stressed atmosphere. We're watching the foundation of South Florida dissolve beneath the surface. The river of grass is dying, and it's taking everything else down with it. So here's the question, keeping Everglades researchers up at night. Are we watching an entire ecosystem collapse? Or are we watching something adapt in ways we're not ready to understand? Drop your theory in the comments. And if you want to see what researchers are discovering as they track these underground movements in real time, smash that subscribe button. Because what's happening beneath the Everglades, it's only the beginning.